Now take an example. You have to evaluate the integral, that is a triple integral 1 to 2, 2 to 3, 1 to 1, 8xyz dz dx dy. So first we have to notice the order of integration. Here first we have to integrate with respect to z, then x, then y, and the limit of the integration, all the limit of integrations are constant. So here the limit of z is what, 1 to 2, as according to the order of integration, and with the limit of x is what, 2 to 3, the limit of y is what, 1 to 2. So first we have to integrate with respect to z. So we write 1 to 2, 2 to 3, and we take the integration with respect to z. So treating x and y as a constant, so we write 8xy z square by 2, so we write 4xy z square, and apply the limit on z square, that is 0 to 1 dx dy. Now when you apply the limit we get 1, so the remaining integral is 1 to 2, 2 to 3, 4xy dx dy. Now we take the integration with respect to x, and what is the integration of 4x square, 4xy, we get 4y x square by 2, that is it become 1 to 2, 2 with y x square, and apply the limit 2 to 3 dy. So we get 1 to 2, we can also write 2, and apply the limit y x square, that is 9 minus 4 dy. So we get 1 to 2, and 9 minus 4, that is 5, 10 y dy, and on integration of 10y we get 10 y square by 2, 1 to 2. So we get 4 by 2 and minus 1 by 2, we get 3 by 2, that is we get 15. So the value of that integral is we get 15. So here you have to notice the order of integration is according to the limit of integration. So we take one more example. In that we have to evaluate the integral, triple integral, but the limit of integrations are not, all are not constant. Here 0 to 1, with 0 to root 1 minus x square, 0 to under root 1 minus x square minus y square, and the function is 1 upon root 1 minus x square minus y square minus z square dz dy dx. So when you see the integral like this, so first you have to search the limit of integration, that is here the limit 0 to 1 minus x square minus y square. So that is what, that is a function of x and y, so we can say that's the limit of z. And the second one, this one here, this is the limit root 1 minus x square, so this is the limit of what, y, and the limit, so that's the limit of z, this is the limit of y, then definitely that's the limit of x. So here first you integrate with respect to z, then with respect to y, and then with respect to x. So start, first we take the integration with respect to z here. So we write 0 to 1, 0 to root 1 minus x square, and we take the integration with respect to z, treating x and z, x and y is a constant. So most of the integration of that, that's in constant part, and 1 upon root 1 minus z square, we write sine inverse z upon root 1 minus x square minus y square. So we apply the limits 0 to root 1 minus x square minus y square dy dx. When you apply the limit here, so we get sine inverse 1 minus sine inverse 0. So what we get, 0 to 1, 0 to root 1 minus x square, and we get sine inverse 1, that is pi by 2 minus 0. So we get dy dx. Now take the integration with respect to y. So we get 0 to 1, pi by 2 is a constant, so we write pi by 2 y, apply the limit 0 to 1 minus x square root 1 minus x square dx. Here we get 0 to 1, sorry, we write pi by 2 outside the integral, that's a constant term, and root 1 minus x square dx. And the integration of root a minus x square, so we write what is the integration of that, that is we write x root 1 minus x square by 2 plus 1 by 2 sine inverse x, limit 0 to 1. So when you apply the limit 0 to 1, we get here pi by 2 is outside, we get pi by 4. So that's we get pi square by 8. Now we take an example. Here we have to evaluate the triple integral 2x plus y dx by dz, and on the region V, where V is a closed region bounded by a cylinder and the plane x equal to 0, y equal to 0, y equal to 2 and z equal to 0. So here first we plot that particular region, so it is easy to find the limit when you see that graph. So here as you see, z is equal to 4 minus x square, so that is that's in surface z is equal to 4 minus x square, and the plane, as you know, x equal to 0, so that's in plane x equal to 0, that's a plane, and y equal to 0, so means where y equal to 0 is that plane, and z equal to 0 is that xy plane, and when we say y equal to 2, so somewhere the line, that line y equal to 2, so the region V is what is in the first quadrant, so in that region we have to evaluate that particular integral. Now first we find that that points, that's an interesting point. As you know, here z is equal to 0, when we put in that equation z equal to 0, so we get x equal to 2, that is plus minus 2 means that's a point, x is equal to 2. And similarly we find that point if we put x equal to 0 on that plane, so we get z is equal to 2, and that's a point equal to 2, so the coordinates are 0 0 0 to 0, and that's in 2 0 0, and that's in 0 0 4. And similarly you also easily you can write the coordinate of t, that is 2 2 0, and the coordinate of p is 0 2 4. Now here the region V is what is, we write, if we say that's an origin O A B C D E, so in that region you have to evaluate that integral. So first we write the limit of integrations, that is the z. First we take a z, suppose here if we take a small part of that region, so z, we can say z varies from 0 to what on that surface, the equation of that surface is what, 4 minus x square, so we say z is varies 0 to 4 minus x square, right? Now then what's in where the y varies from 0 to that line, that is y is varies 0 to 2, and similarly x varies 0 to 2. So the integral, the limit of integration is 0 to 2. We write 0 to 2 and 0 to 4 minus x square 2x plus y. First we take the integration with respect to z, then you can take the integration with respect to y, and then x. So here first we take the integration with respect to z because the limit of integration of z is what? In the function of x. Now when you take the integration, you write 0 to 2, 0 to 2. When you take the integration with respect to z, treating x and y as a constant, so we get what? Only z. Apply the limit 0 to 4 minus x, so you write 2x plus y and 0 minus, that is 4 minus x square dy dx. On simplify, you get 0 to 2, 0 to 2, and when you multiply 2x into 4, so I write it what, that is 8x minus 2x cube plus 4y minus x square y dy dx. Now we take the integration with respect to y. You also take the integration with respect to x first because both the limit are constant here. So we take the integration with respect to y. We write 8xy 2x cube y plus 4y square by 2. I write 2y square minus x square y square by 2. Apply the limit 0 to 2 dx. So we get 0 to 2 and we get 16x minus 4x cube plus 8 minus 2x square. Now take the integration with respect to x and apply the limit. So you get, when you take the integration, we get 8x square, that is an x square by 2, we get 8x minus, that's an x 4 by 4, so 4 will be cancelled, we write minus x power 4. Similarly 8x and minus 2 by 3 x cube. You apply the limit 0 to 2. So what we get? We get 32 minus 16 plus 16 and 2 by 3, 16 by, we get 3. So on solving that we get 80 by 3. So that's the value of that integral in that particular region. So in this way you can evaluate the integral in the particular region. So whenever you take the you are doing the triple integral, please take care the order of integration. In that order, how you take the limits. If the limit of z in the form of xy, so first you take the integration with respect to z, then see the limit of y, and then see the limit of x. In that case, we also on that step we also take the integration first with respect to x, then y.